right, let's go over the answers to that specific heat lab where you're burning the chip. So I know if you're virtual, you weren't able to do it, but at least I gave you the data, and then what I wanted you to do was answer the questions considering the data. So in that lab, remember, you're trying to burn a chip. What we're going to try and do is we're going to collect the energy that that chip gives off. Right? And in order to do that, we're collecting it in water. And what we're looking at is how much does the temperature of that water go up. And based on how much that temperature goes up, it can tell us how much energy that chip gave off. Right? Now, we are assuming that we are collecting all of the energy from that chip. The unfortunate piece is now we are going to miss a little bit because a little bit is going to go off into the atmosphere. But again, we're making an assumption to identify that or say that, yeah, we did collect every bit of energy. All right. So according to the data that I gave you, it said the chip, your starting mass of the chip was 2.8 grams. The final mass afterwards was 2.4. Right? Now, I don't want you to think that we destroyed matter, because we can't destroy matter. What we did is some of that matter floated away as gases, right? And based on that, tells us how much of it was broken apart. Right? That's what we're looking at. It didn't get destroyed. And then the temperature change is not the temperature change of the chip, it's the temperature change of the water, actually. So when it started at 23 degrees Celsius and the final temperature was 70 degrees Celsius. So the temperature went up, the water warmed up. All right, so now as we go down through there, question letter A says M equals the mass of the 50 milliliters of water. And I gave you a hint underneath saying that 1 milliliter of water is 1 gram. So if you have 50 milliliters of water, then the mass should be 50 grams. All right, so the mass of that water that's inside the Erlenmeyer flask is 50 grams. Letter B is, what's the change in temperature? Well, what's the change in temperature? Well, it went from 23 degrees up to 70. So what we have to do is take those two, take 70, subtract 23, and you get a change in temperature. The water changed in temperature by 47 degrees Celsius. That's how much the temperature went up by, was 47 degrees Celsius. Then letter C is, I'm giving you what is the specific heat of water. Right, it's a very specific reason why it's called specific heat. It's a very specific number for water, which is 4.19 joules per gram degrees Celsius, which we talked about in the notes, that's the unit for specific heat. That number is not going to change. Right? It is a specific number for water because we're looking at how much energy that water collected. So when we get to letter D, we're going to do some calculations. So in this one, we got Q equals, well, we got the temperature change, well, we just calculated that above. Sorry, I'm going to sneeze. That temperature change was 47 degrees Celsius. Then we're multiplying that by the mass of the water, which is 50. Don't utilize the mass of the chip, because again, we're measuring the energy that water collected. Right? And we're going to assume that is the energy that the chip gave off. So we got 47 degrees Celsius, that's the temperature change. We got 50 grams is the mass of the water. And then CP, that's the specific heat of water, which is 4.19. Right? So you multiply all those things together, you get a big, humongous number, 9,846.5. And then actually what ends up happening is grams cancels out, and degrees Celsius cancels out, and our units are joules, or J. So 9,846.5 joules. So now we go to letter E. Now change Q, which is the heat, to calories, right? Which is something that we're more familiar with. Because like when you drink this, you drink a cup of Pepsi, on the back side it tells you, in this area, it tells you, well, if you drink this, how many calories did you consume? All right. So, and we're going to talk about what this calorie is in a minute, but that's really what we're trying to compare this to, is this area back here. And when they figure this stuff out, they actually do a lab very similar to what we've done in class. Right, is that they burn the food sample, they collect the energy in water, and then they do all the calculations that you're doing here in order to figure out how many calories of energy came off of that. Right? And the thing that they actually use is called a calorimeter, which is a device that's very similar to what we made in class. So you're going to take Q, which is what you just figured out in letter D above, which was the 9,846.5 joules, and you divide that by 4.19, because 4.9, that's joules, and there's 4.19 joules per 1 calorie. So if you divide that out, you get 2,350 little c calories. Now I'm going to put little c on it because there's two different types of calories that are out there, and that's what comes next in this paper. So it says, note, there are two different calories. One is written with a lowercase c equals little c calories, but the other is written with a capital C, big C calories. And those are actually kilocalories. Oh, kilo. Now we got to go all the way back to the beginning of this course. And in the beginning of this course, we talked about the metric system. And we talked about kilo, mega, giga, tera. Well, what is a kilo? A kilo is 1,000. So a kilocalorie, a big C calorie, is 1,000 little c calories. I know it's confusing, and why do they have to use the same name? I don't know, but that's what's used. Okay, so these are little c calories, but the big C calories we use on chip bags are actually kilocalories or 1,000 calories. Same thing on this. The calories that you read on the back side of this can, those are kilocalories, not little c calories. Okay. So we're going to take our answer and divide it by 1,000 because the answer we had a moment ago, which was 2,350, that's little c calories. We want to change that to big C calories, the calories that we read about all the time. So you divide that by 1,000, you get 2.35 kilocalories or big C calories. So that means that one chip, that chip is 2.35 calories that we're used to. Right? Doesn't seem like a whole lot, man. Two calories, that's no big deal. I eat that chip. The question I'm going to have in a little bit is, do you usually eat just one chip? I don't know about you, but I usually eat one bag of chips, and that's not one chip. That's more like a whole bunch of chips, and every single one of those chips is 2.35 calories. Now, how am I going to get rid of those calories that I just ate? Well, I got to burn them off. And if I'm going to burn them off, that means I got to do something in order to burn it off, which we did a lab earlier where we did the idea of climbing up the steps out at the football field. And it took a certain amount of energy to climb up those steps. So how many times going up and down those steps do I need to do in order to burn off that whole bag of chips that I'm going to eat? Because if I don't burn it off, then what happens? Well, it goes right down here. Right? It makes me look like Santa Claus. So and I don't want to look like Santa Claus. But all right, so we got 2.35 kilocalories, or big C calories, is what that chip produced. So now letter F says heat absorbed per gram of food burned. Use the difference in the mass of the chip from the table above to determine how many grams of the chip was burned. Now remember, we started with 2.8 and we ended up with 2.4. So I'm at 0.4 grams of that turned into a gas and went floating off into the air. Right? So we're going to calculate a new Q, heat, and we're going to divide your answer from the letter D above by the mass of the chip burned. So the letter D above we had was 9,846.5 joules. We're going to divide that by 0.4 grams. So we're going to find out how many joules of energy there is per 1 gram of chips, because we didn't even burn a full gram. Okay, we only burned almost a half. We end up with 24,616 joules of energy per every gram of chip that you burn, right, or eat. All right, so that's the answer for that one, is 24,616 joules per gram. So now the very last question down here says, if you expend 2 kilocalories every minute while walking, how long would you have to walk to burn off one chip that you burned? So now I got to go all the way back up and pull the answer from letter E above, which was 2.35 calories is what we get from that chip. If I'm going to burn 2 kilocalories for a minute, then to burn off that one chip, you're going to take 2.35 divided by 2. And you get an answer of 1.18 minutes per chip. That's no big deal. I walk for a minute, that's no problem. But remember, that was if you ate one chip. And we've already discussed, again, I don't know about you, but I can't eat one chip. I got to eat one bag of chips, which might be 100 chips. Well, that means if I eat 100 chips, then I'm going to take that 1 minute, multiply it by 100. I got to walk for 118 minutes. That's a lot. There's 60 minutes in an hour. 118, that's almost 2 hours of walking just to burn off that bag of chips that I ate if there was 100 chips. 2 hours of walking. That's a lot of walking. All right. So the concept I wanted to get off this is that, I mean, we can measure, and again, that's what they're measuring when they give you this part on the backside of a can or the backside of a bag of chips or the backside of anything you eat, is how many calories you have to burn in order to get rid of that. And if you don't, then again, it goes right down here and makes myself into Santa Claus. Right? So that was the concept behind this whole idea. Right? So going over to the last few questions there again, it's how many minutes would you have to walk to burn off 100 chips? Well, that's what we were just talking about. In this case, it'd be 118 minutes per bag, which would be like 100 chips. Right? That's almost 2 hours worth of walking. Yikes. That's a lot of walking. Right? And that bag of chips, that's not the only thing we eat. Because then we might add this to it, and this might add another 100 and some calories. Right, or even 200, and then it's like, I'll have a couple of these. Let's have 2 or 3 cans of Pepsi. Okay, and all of a sudden, oh my word! Now I'm up to, I got to walk for like 6-7 hours in order to burn off my couple cans of Pepsi and my bag of chips. Oh, let's have a candy bar with it too, and that adds even more. Oh my gosh, I'm up to like 8 hours of walking in order to burn this thing off. I hope you see how this like starts multiplying, and we start like, man, we got a lot of stuff to do in order to burn off all the stuff that we eat. Okay. Now again, just living, just being does burn some energy, right? But it doesn't burn the kind of energy that we get from this or a bag of chips or a candy bar, right? Just being helps burn off the food that we eat for dinner, lunch, breakfast, right? It's all these little snacks in between that start to add up, and especially when they're something that's really high in calories, right? Got lots of sugar in it, but it doesn't give us any protein or anything like that. That actually gives us some substance, right? So, all right, well, I hope you learned something off of that one. So that's the end of that one. You have a good day. We'll see you.